Hello guys, how are you doing? Today I'm going to show you spatial analysis with the attribute data, and here we are going to see the join and the relate function, especially the join function. We have two join functions, spatial join function and the table join function. A spatial join function, as the name implies, we can join the two layers with their attribute tables. So it joins attribute from one feature to another based on the spatial relationship. And the second one is table join function. If you have two layers, one has a large number of or large volume of attribute data, and the other has limited attribute data. For example, if you have Warada and towns of the Warada feature, and the layers of the town has, if the layers of the town has large volume of attribute information like population, rainfall, temperature, and soil pH, elevation, soil erosivity, and some cereal production, right? And this, if these are not found on the Warada table, you can join the uh, town layer with the Warada layer using the spatial join function, or you can join the table of the town with the table of the Warada using join function. So then, after joining that, you can analyze the spatial information, especially on the Warada level. For example, if you have the elevation data of each town, you can interpolate that elevation point data on the Warada level, and then you can analyze the spatial distribution of elevation or the spatial information about elevation. And the same is true for rainfall and other spatial data. So let us see. Here we do have this data. We don't need the line data. Again, we don't need this region data. Okay, here we do have this. Again, water. We don't need this zone. We need only water in the town. These are Oromia towns, and this one is Oromia waradas. Let us explore the attribute information in each layer. For example, town, open the attribute information or the table of the town. You see, it is really rich in attribute information. Here it has this field ID, shape, object ID, town name here, each town name, population of each town, Warada name, region name, zone name, population, urban population, rural population, total population, rainfall, K value, soil, and soil value, soil erosivity, elevation, and on, okay, and on. So this is important information. So let us again explore information or attribute information of the waradas. You see here in the warada we do have limited attribute information which relates to the warada. For example, only warada name, field ID. Here we have the maize production and area, shape length, shape area, and the total area of each warada. We don't have rainfall data, we don't have the soil data, we don't have the elevation data, and again, we don't have erosivity data here. But we want to, interpolate rainfall, interpolate elevation, and we we want to analyze the spatial information about rainfall element, and right click on this and go to property and go to symbology. Here go to this analysis, unique value. By unique value you can generate, for example, the maize production or population by unique value. It is very big data, but instead of that, here we can use graduating value. The value, for example, should be, for example, rainfall. You see, rainfall across Oromia region, and you can select appropriate color for your rainfall information using graduating color. Okay, so 5 classes. If you need to 10 classes, you can use these 10 classes. You can use graduating color, right? And let us see full extent and then check the town. You see, by joining that information from town to this Orada using spatial join, now we generate or analyze the spatial analysis of different spatial information. For example, the rainfall of our Oromia region looks like this one. Which part of Oromia receive high amount of rainfall? As you see from this legend here in the table of content, the western part of Oromia receives a high amount of rainfall per year. Okay, especially this one from 1981.5 millimeter up to 2275.7 millimeter, especially this area. Okay, this area. Last time we have seen this area receives some amount of rainfall, as well as it is the major maize producing region. So we have seen that rainfall and maize production have what? Correlation. In the area where there is high amount of rainfall, there is high amount of maize production, right? But when you see the west, the eastern part and southern part of Oromia, and the southwestern central part of Oromia, there is low amount of rainfall, especially in this area, this red one. It shows low amount of rainfall. In such a way, we can analyze the spatial analysis. Right. The other method of analyzing this spatial data is drawing graph or charts. Go to this chart. We can generate or produce charts, pie chart or bar chart, bar graph. Okay. For example, if you choose this chart and now select the element or the data that you are gonna to map, move to this box, okay, and you can add one more. Let us add this one, okay, and you can change the color and as you like, as you want. And apply it. You see there what happened there? This one happened, and still we have to manage our color choice. Okay, we'll change if needed. We'll change it, but still, it is not on the right place, so we can manage the size of each go to this size, right? So can decrease the size to the manageable way. You see, no? Somewhat to basically each algorithm like this. You see here, this is the pie chart for rainfall. This rainfall, let's make it rainfall here. Okay. Let's make it rainfall somewhat this one. And erosivity can't be green. This erosivity. Okay, maybe you can make it like this. Erosivity elevation. Okay, instead of this, let us make it low. And now you can apply this for clear information. It looks like this one. Okay. So this is the what the pie chart of our spatial information. So we can draw pie chart for our spatial information. It is especially important and powerful to deliver information to readers. Okay, the next one is the bar chart or bar graph. We can draw bar chart or bar graph. You can go to here again, or yeah, here, and again you can go to this one. Instead of this, basically, first of you can save as layer this one. Attribut is save as layer. Okay, if you need, you will access it. Now you can generate your bar graph. Go to bar, simply you can draw it. You see, this is your bar graph for your information. You can manage it, by the way. You can, you can here go to the property, and here you can manage the size, and here the normalization, and you see here, this is the size. You can increase or decrease the size, and you see here, you can make it 3D, right? Okay, access, no need of access. Show what? Again, extra, you need extra style. You can you can yeah, it is working. Please, it is 3D, it is working. Yeah, it is like this. If you need a 3D, three-dimensional, and you can zoom into your area of interest. Takes time because now it is processing. Yeah, this is the information, spatial information presented using the bar graph of rainfall, erosivity, elevation, and soil. Okay, this is how to draw the chart and how to analyze spatial information. And even this tells us about the relationship between rainfall, erosivity, elevation, and soil, right? Okay, and you can save this as layer, and you will display it. Okay, as layer, this one is 2. Okay, and next step or the next activity will be what? Next to this, what we should do? Oh, we have seen this all and the bar, all right, and the bar spatial population, metro population, and here another activity, dissolve, can dissolve, can clip, dissolve, simple things are there. Now the other important thing is interpolation. You see, interpolation. Most of the time we can interpolate what? Point data. Right. Ready? We have finished this one. So let us back to the our data. By the way, after having analysis on your data, immediately you can go to this property and go to feature. Simply, you can back to your feature data. Looks like this one. Unless in otherwise, you open and see the attribute table. You see, when you see this attribute table, all the information is are there, but it is the raw data. We make it back to the raw data. So we're gonna to analyze some analysis on it. For example, interpolation. Interpolation. Which one is the point data? Here, this is not in the point data, right? This is the attribute data on the polygon. So what we are going to interpolate? Most of the time we can interpolate point data. What is our point data? Here we do have this. Uncheck the order in the zone. Here we do have this point data of Oromia. What is there in the point data? We do have the what? The population of Oromia region, the total population, urban population and rural population, rainfall, and the soil and erosivity, elevation. We do have this very important spatial information with the point data. That means with the location, that means with the XY location, latitudinal and longitudinal location. That is very important thing. So now we want to analyze this spatially across what? Across this, across Oromia region. Okay, across this region, Oromia region. You see, but we do have what? Point data. Now we are going to make it more of spatial data, and we are going to analyze the spatial relation or spatial distribution of this data, rainfall, the population, the elevation, and on. Okay, so the next thing is go to your ArcToolbox. By the way, you can access ArcToolbox from the search by using this search bar, or you can access from here, you see, from Spatial Analyst. So you can expand and go to interpolation, and here you have a bunch of interpolation functions. Right, first off, let's this one. You see, point data, the z value, the value that you are going to interpolate, z value, very important thing. We are going to interpolate, for example, rainfall. But one thing you have to keep in your mind is that before any interpolation analysis, you have to have the environment setting. Don't forget this. environment setting, right? Go to here, this workspace already to have this, forget about that. And coordinate already will use same as input, right? And extent, very important thing, this extent. What will be the extent of your interpolation, okay? If you interpolate without the extent, you will see what it looks like. First, let's see what it looks like without setting the environment. Okay, down, there is rainfall and our output here. Okay, rainfall, IDW interpolation. Okay, output cell size. You can manage the cell size. Here, cell size means the pixel size, right? This determines the resolution of the output. Okay, so for the time being, let us use the default, and then okay, let's say okay. This is without environmental setting. Let us see what happened. You see, this is without environmental setting. It looks like this one. See, it looks like this one. Gonna check this. You see, without what? Environmental setting. This is rainfall. Already we have seen there is high amount of rainfall in the western part of Oromia region, and low in the southern and eastern part of it. But it is not fit to the what? The border of Oromia region. So how can we do that? We have to set the environment. Go to environment setting, go to extent, and not default. Now the extent should be, you see, same as layer of Oromia region. Snap raster, okay. No raster here, okay. And this mask, Romeo Radas. Okay, now, okay. And then go to IW and Romeo Thames, and again rainfall. The second time rainfall IW2, save it, and then let us run it. It was finished. What happened? And check the previous one. You see, this happened. That means this one, the previous one, you see, the previous one were not accurate, especially in this area, in the western part of Oromia and the eastern part of Oromia. But the second one, you see, it fit to the what? The boundary or border of Oromia region, right? So before any, not only interpolation, any raster analysis, you have to set the environment, then you will be effective in your analysis, spatial analysis, especially if you are going to have this output, the input for your model, like suitability analysis or any other model like Russell model input. Here, environmental setting is very important. That means you will have all the individual output with the same what pixel size as well as the same coordinate or reference system, right? So, and finally, you will have a good output or integrated model input, and finally, you will have model. So environmental setting is very important. And one more thing, this is about rainfall. This tells us, you see, here you can see this one, the table of content in order to analyze the rainfall. The western part, as we have seen earlier, the western part of Oromia, especially the western central part, receives high amount of annual rainfall, and the southern as well as eastern and southeastern part receives low amount of annual rainfall. Okay. One more thing, let us interpolate the elevation. Now already we have set it, so we can, by clicking other method, this down, the next thing, elevation of Romarada, this one, elevation by clicking interpolation method. Okay, this shows that the length, it about the length, click, you can say click, still not okay. So ellipse, okay, now it may be okay, yeah. Elevation cleaning, by the way, this case sensitive. Output cell size should be the default. And again, okay. Yeah, this is elevation of the spatial distributions of the elevation of the what? The Oromia region. You see, by the way, it is really, really important information. You see, this part of Oromia is the highest part, the highest altitude part of Oromia. Yes, Arsibale Mountain, it is true, we know that, right? The Arsibale Mountain, the highest peak in Oromia region, right? This is Arsibale Mountain. And here around the western part of Addis Ababa, the uh, the mountain chains of Doto of Addis are some highest part of Oromia region. Whereas when you see this part, the green, the southern and the southeastern part of Oromia, the lowest point of Oromia or the lowest area of Oromia region. And then you can also change this color, the default color. This is the default color, but you can manage to change this, and you can also reduce the class into 5, and you can change this into your interest of the color, and then you can manage here the decimal number. You can manage here, right? Go to again here. You see here level. You can manage here this. You can round off it to this one. Should be 5. Okay, and then this from this up to this range. You can round off. You can round off this. You can round off this. Should be 6, right? You can round off this, and you will have smart output and legend as well. Should be 6. Okay. Okay. Yeah, this one. So you can insert. So you can go to this view. This is the what view, and you can change this. Instead of this one, it should be this one. It is based on the shape of the what the layer, which is in this case Oromia, and then you can insert the legend elevation. Yes, here elevation. Wait, that's this one. Only this elevation. Okay. can also have this one. It is unnecessary. Okay. Again, this one, the title should be. Still, you can avoid this and go to this legend, and here it is what elevation of our marriage. Elevation under meter, under bracket or in bracket, elevation in meter of Oromia region. Now you can insert the other element, especially you can insert in order row. Okay, can put it appropriate place, and again you can insert the legend and the scale bar. Should we go to property, and there should be kilometer. Not only kilometer, here make it in km. Should put here, should be visible. Okay, other thing you can also insert what? The grid, which is very important now that tells us about the location of each place. So you can insert grid, right click here, go to this property, and then go to this grid and new grid. Here can insert that and grid and go to this property, and you can okay, 5 and all right, the default. Let's see the default here. Okay, go to level left right reading should be don't show interval. This one we will just already did it. Still not visible. Not visible means it is got level, and again increase this font size. Now it is somewhat visible. Okay, and again go to property. Okay, should be top left. Let's make top left over this, and again increase this one to this one. Top left, level right, top left. Okay, line interval here should be again 1, the x-axis. Okay, so it should be like this. See, top left. Is enough top left, or top right is enough, right? Because it is information redundancy. So to avoid that issue, we can use only top left or top right. In this case, we use the top left. If you need, you can change to the top right. It is all about here. Still, the font size is not readable. You can make it here. You can change the color if you need, or if you are interested in the different colors, for example, in blue, make it like this blue, and then here it is. Now you can add neat line, which is very important. Insert a neat line. this init line is around place around selected, and it should be, this is very important, especially like this. Okay, yeah. So now you have finished. You can export this, export, and okay, on desktop somewhere we can put it. Untitled, it says untitled. Save it. Then basically you can save it in your appropriate folder. Okay. Now this is how to generate spatial information using attribute table or attribute information. And in order to access attribute information of one layer, we can use the join function. We have two types of join function: spatial join and table join function. By using this join function, we can join two attribute tables of two layers. So we can map and analyze the spatial information like this. Thank you for watching. Next time I'll show you how to analyze surface analysis. Till then, see you.